Okay, oxidation number means it is the number of electron lost or gained during reaction. Write that. It is the number of electron lost or gained by an element when they react. Okay, so all uncombined before undergoing the reaction. Say for example, if I say there is one lithium atom there without any other atom, we would say the oxidation number for lithium is what? 0. So if we have hydrogen by itself without connecting, without combining with any other element, the oxidation number will be 0. If we have carbon by itself, that will be 0. If we have zinc by itself, that will be 0. Because it doesn't combine with any other element. All uncombined element has a 0 charge. Okay, so we are using the normal rule to decide which one has charge. So you on your paper it is given oxygen always show -2, hydrogen always show +1. Okay, oxygen always show -2 as of now, but there are peroxide. Peroxide has a -1 oxidation state, but for your AOL you don't need to know that. So oxygen has a charge of 2 and hydrogen has a charge or oxidation number +1. But I know you know the charge of first group metals, they are +1, second group metals +2, and halogens are -1. But there are few exceptions. In addition to that, they will show multiple charges. So we are going to see how we can calculate those charges. Okay. Then if we see a compound, okay. If we see a compound, say for example sodium chloride, what will be the total charge for the compound? Sodium will be what? +1 and chlorine will be -1. So what will be the total charge? So all compounds will have a total charge or a total oxidation number will be 0. Sum of the oxidation number for a compound will be 0.
Wait, so all compounds no matter what?
Yeah, if you are writing potassium sulfate, the charge will be 0. If you are writing hydrogen chloride, charge will be 0.
But what if it's like sodium sulfate?
If it is sodium sulfate, charge will be 0. If the formula is correct, because that's why they are reacting. One is losing electron, one is gaining electron, okay? The number lost by one element must be equal to the number gained by another element. Total number of electrons must be equal. Okay, so all compounds will have total charge or total oxidation number is what? 0. All compounds will have total charge will be 0. Question. Okay. Then if you see a polyatomic ion, say for example I am writing phosphate. What is the charge for phosphate? Yes, that is their charge. Their charge will be equal to their oxidation number because they are not equal to 0 because it is only a part of a compound. Okay, polyatomic ion by itself is not a compound. It is just only a part of a compound. Say for example, if we say K3PO4, we know that PO4 is only the half of a compound. That is not 0. It has a charge. Whatever the charge it is, you have to assign that charge. Say for example, if it is nitrate, charge will be -1. If it is carbonate, charge will be what? +2? -2. Okay. Those are the rules we need for assigning oxidation number for other elements. We are going to use all this rule. So, as of now, you have to memorize oxygen is -2, hydrogen +1, all group 1 and group 2, whatever the charge they have, that's a charge for them. And halogen, if you don't have the charge of other elements, we will assume halogen is also showing -1. But except fluorine, all other halogens are showing multiple charges. We are going to see that today. Okay. Next heading, oxidation. Another terminology which is oxidation. Oxidation means removal of electron. Removal of electrons. Say for example, if I have a zinc atom, if it is by itself, we know that it has a charge of 0. It is combining with someone. I don't know who it is, but I'm just writing. After combining, it lost 2 electrons. So it become 2 plus after releasing 2 electron out of it. So this is called oxidation because electrons are removed. Losing of electron is called what? Oxidation. Okay, what happened to the oxidation number? It was 0, it changed to what? 2. Is it increased or decreased? So we can say oxidation is increase in oxidation number. Increase in oxidation number. Okay, now write reduction, which is just opposite of that. Reduction. Addition of electron or gaining of electron. Gaining of electrons or addition of electrons. Say for example, I have an ion which is a part of a compound, maybe from a single or double replacement compound, which is Cu2 plus was initially. It gained 2 electron and now converted into what? Cu0. This is called reduction because what happened to the oxidation number? Decrease. Decrease in oxidation number. Okay, if you are a visual person, if you want to draw a number line, put 0 in the middle, 1, 2, 3, missing 1. 1, 2, 3, 4, and here it is what? -1, -2, -3, -4, and it is a line, it is continuing, okay? And write red ox. Redox. Okay, I'm going to give you an example. You have to tell me whether it is red or rocks, okay? Ag plus 1 to Ag.
Red.
Okay, we are having number 1 to 0. Are you going left or right?
Left.
You are going from 0 to 1, so that is what? Reduction. Okay, let's do another example. If you have Cl2 to minus 1, oxidation number is 0, it changed to minus 1. So 0 is here, we are going to the
Reduction.
left, that will be what? Reduction. So we are going decreasing number, so that is reduction. That's how we are deciding from the number line. So if we have Fe2 plus changed into Fe3 plus, that will be what? 2 to 3. 2 to 3. Is it? Going towards this direction, that will be what? So if you are going to right on the number line, that will be oxidation. Going to the left, that will be what?
Reduction.
Question. Okay, now redox reaction is a reaction in which both of this will happen simultaneously. Go ahead and write the definition. So redox reaction means both oxidation and reduction undergoes at the same time. You can say what? Simultaneously. Okay, I'll give you examples in a minute after we do couple of oxidation thing, okay? Okay, I'm gonna give you an example. So, potassium sulfate. This is a review of what we learned while we learning the ionic compounds for assigning oxidation state, okay? So, I got a compound. I know that potassium will always show what? +1. And oxygen is also given to you. Oxygen will also show -2. That is given to you on your note paper, okay? Oxygen will form -2. Hydrogen will form +1. Okay? And sulfur, by normal knowledge, I know it is -2, but sulfur can show different oxidation states, so I don't know the oxidation state. I'll put a variable there, X. Then one thing I know, the charge of a compound will be what? Anyone? 0. So I'm going to make an algebraic equation. 1 times 2 will be 2. And there is only one molecule of X, so that will be X plus -2, how many atoms? 4, so -8 equal to 0. So I'm going to solve this. X minus 6 equal to 0. So X will be equal to what? +6. So I found the oxidation state of sulfur, which is +6. Good? Try another example. Okay. Let's do calcium carbonate. Calcium carbonate. Right. Calcium, what is the charge of calcium? 2. And oxygen? -2. And carbon, I know it is plus minus 4 from my basic knowledge, but it may show different oxidation state. Let's see. Go ahead and calculate. Make an algebraic equation. The total charge must be equal to 0 because it is a compound. So there is how many calcium here? 2 calcium? Just 1. 2 times 1 is 2. 1 carbon minus what? 6 equal to 0. So X will be what? Plus 4. This is how we are finding the oxidation state. Some of them we can do. We don't need to always do the algebraic equation. If we can do mental calculation, go for it. Okay. So now, get this paper. And I will review one more time the rule we discussed. Uncombined element is what? Uncombined element is 0. Then combined element equal to the charge of the ion. So we said if it is group 1, that will be plus 1. Group 2, that will be plus 2, like that. Then for a compound, it must be equal to it added to what? 0. For all compounds, total charge must be 0. Polyatomic ion will be equal to its charge. Don't worry about this. Okay, oxygen will show negative 2. As of now, you can learn like that. There are exceptions. Hydrogen is what? Plus 1. Okay, now we are going to find oxidation state of these elements. Okay, let's start from first example. I will solve one. You are going to do all this by yourself. Okay, so potassium plus 1, oxygen minus 2, chromium X. We know that the total charge equal to what? 0. So make a algebraic equation. So 2 times 1, it is 2. 2 times x is 2x. 7 times minus 2 is minus 14 equal to 0. So 2x minus 12 equal to 0. 2x equal to 12. So x will be what? 6. That will be plus 6. Good? Let's try the next one. FeO. We can do mental calculation here because that is not a complex molecule. Oxygen is what? Negative 2. So this will be what? Positive 2, because what added to negative 2 gets 0. So, or if you need an algebraic equation, write x minus 2 equal to 0. X equal to what? 2. Okay, try the next one. Cl2. Uncombined element, so that will be what? 0. Okay, now you go try this one. Find the charge of ion. Oxygen is minus 2. Give you a few seconds to try. Got it? Okay, what is the charge here? 2x minus 6 equal to 0. So x will be what? X equal to plus 3. Question. Okay, now go ahead and finish that examples. CO2. Plus 5. And this one. -3, okay. And this one, +2. Okay, now we are going to decide the oxidation or reduction. For that, there is a mnemonic we can, I don't know if it's mnemonic or abbreviation. It says oil rig. Oil rig, the expansion is oxidation is losing electron and reduction is what? Reduction is gaining electron. Oxidation is losing and reduction is gaining. Okay? Oil rig. Okay, now let's do few questions. Okay? From here. Copy this. Oxidation is losing electron, reduction is gaining electron. Hey, so we have couple of examples given. Oxidation state is also given, so that is easy, but you will not get that question on your AOL. You have to actually find the oxidation state, okay? Here it says Fe was 3 and it changes to what? 0. So what happened to the oxidation number? Look at the number line. Is it decreased or increased? If it is decreasing, what? It is reduction because it is decreasing oxidation number. Okay, next one. Cr2 plus was reactant. It has +2. Now it is +6. So number change from +2 to +6. Going to the right or going to the left? Okay, redox, remember. So this will be what? Oxidized. So number line will be like this, redox. If you are going to the right, that is oxidation. Going to the left, that will be reduction. Okay, next one. -2 to +2. Oxidation. Next one. -1 to 0. Oxidation. Good? Alright, now we'll see the actual question you are going to see on your AOL. These equations are not balanced. I'm not going to teach balancing right now. I believe now everyone can do balancing. Do you? Yeah, okay. Let's see this. First question, we are going to find what are the elements from the reactant side undergo oxidation and which one undergo reduction, whether it is a redox reaction or not. Okay? So let's see. I'm going to always, whenever I see the single element, I will go write 0 there. So problem solved for that. Okay, now I have to find the oxidation. I am going to assign the oxidation state for each and every element. Oxygen is -2 and iron will be what? 3 times 2 minus 6, 6 divided by 2. We already calculated here, which is what? 3. So this is 3. Okay, here we don't need to calculate. We know that oxygen is -2. This will be +2 divided by 1. So that will be what? +1. You are writing only one atom's charge on the top. Don't multiply this with 2 and write +2 there. Okay? You have to write only one single atom's charge on the top. Okay, now going to see which one undergo increase in number, which one undergo decrease in number. Okay, look at hydrogen. It changes from what to what? 0 to 1. Is it an increase or a decrease? That is an increase in oxidation number. So I'll say what is that? Oxidation. go to the right on a number scale, at a number line, that is oxidation. Now here, Fe, don't have space, I will write here, goes from what to what? Plus 3 to 0. So that is a decrease. So I have to write what? Reduction. Okay, question. Sometimes it will ask which element undergo reduction or which compound undergo reduction. So we can write both. Okay, oxidation is what here? Hydrogen. From the reactant, we are writing only the, don't write H2O, okay? Reactant undergo oxidation to become this. Okay, which undergo reduction? Iron. So I will write iron 3 from which compound? Fe2O3. This is, the whole thing is Fe2O3, but the one which undergo reduction is Fe3. If you practice like that, whenever you see question which compound or which element, you can answer both, okay? Otherwise you will get confused. Oh, this is asking for element. I don't know whether which element I have to pick. So we can avoid that confusion, okay? Let's try the next one. Okay, whenever you see polyatomic ion, same polyatomic ion on both sides of the equation, you don't need to find the oxidation number for each and every element because it is same on both sides. That means we know that no change happened. Okay, I'm going to do like this. Zinc is what? Single elements what? 0 and Ag 0. Okay, now nitrate is -1. There is only one nitrate. So what will be Ag? +1, because the total charge must be equal to 0. Same strategy, nitrate is -1. How many nitrate here? So total negative charge is negative -2. So this will be what? +2. Okay, now we have to decide which one undergo oxidation, which one undergo increase in number. Okay, zinc goes from 0 to 2. So that number increased. I would say that is oxidation. Go ahead and write zinc undergo oxidation. Good. Okay, next one. Ag. Look at Ag. It was +1 in the reactant side. Now it is what? 0. So go ahead and write decrease here. So that is what? Reduction. So you can write Ag plus. That is the one reduced. Or you can write what? Ag from which compound? AgNO3. You all understand now? Let's try the next one. Okay, single element will write what? 0. 0. Hydrogen is what? +1. And how many hydrogens there? 3. So nitrogen will be -3. If you have a problem, just do the algebra and find it, okay? Now, which one undergo change in number? N. N goes from 0 to 3 and hydrogen goes from 0 to 1. So this undergo an increase. Increase what? Oxidation. So write hydrogen. Okay, nitrogen goes from what to what? Left. Okay, it decreased. So that will be what? Reduction. So you will write what? Nitrogen. Good? Question. Okay, try the next one and see. A few seconds. I'll give you 1, 2, 3 minutes. Okay, let's see. So I'm seeing nitrate on both sides, so I'll keep nitrate. I'll keep nitrate as nitrate. It is -1, hydrogen +1. Here also nitrate. There are 2 nitrates, so calcium will be positive. And I'm seeing OH on both sides. Did you see OH on both sides? Yes, because there is water, you can see OH in that. Water is HOH. So this will be -1. So if you are writing like this, okay, this will be -2, this will be +1. Okay, OH will be -1, OH is there, -1, calcium will be +2. Which one undergo change? Hydrogen is +1 on both sides. Nitrate is also same thing, calcium also same, everything, OH is also same. So that means it is not a redox reaction. There is not reduction and oxidation happened. So it is not a redox reaction. Reason, no change in oxidation number. All these equations are not balanced. Okay, I'm not balancing it. Yes. Yeah. No change in oxidation number. Okay, try the next one. Try the next one.
She just wanted to show what
Okay, number 5. Okay, you guys need to try. What is the charge of iron and oxygen? Oxygen is what? -2 and iron +3. Okay, CO, oxygen is -2 and carbon 2. Here, oxygen 82, carbon 4 and Fe 0. Is it a redox reaction? Yes. Which one undergo increase? Which one undergo decrease? CO increased, which is oxidation, and Fe decrease, which is reduction. So go ahead and write it. Oxidation is C from CO. You can write C from CO. And reduction is Fe3 plus from Fe2O3. Yes. Here? No, you can just write the reactant's name. I'm just showing which atom undergo change. What is? Oh, that's what you said. Okay. Yeah, you had to do that. Okay, the question will be asking like this: which element undergo reduction, which element undergo oxidation? So you have to write only the element name, okay? Next one, Al2O3. 0, 0, and oxygen is -2, and this will be what? +3. So which undergo oxidation? Aluminum undergo oxidation because the number increased from 0 to 3. And which undergo reduction? Oxygen. Okay, go ahead and write that. Aluminum oxidation, oxygen reduction. Good? What about this? Waiting for me to do it? No, just to, you all done? Okay, -1 plus 2, -1 plus 1, -1 plus 2, -1 plus 1. Okay, which one undergo oxidation? None. So that is what? Not a redox reaction. Okay, next one. That is easy. 0, 0.
Wait,
What happened?
how do you find the charges of
Which one? Which one you want? Okay, sodium, you know the charges, you can find chlorine. Magnesium, you know the charges, you can find bromine.
Wait, so everything in the first row is negative 1.
What do you mean by first one? Group 1 will be +1, group 2 will be +2. There is no exception for that. Okay, you can use that for finding the charge of other ones. And if you don't have, say for example, this one, look up. This one, you don't know both the charges as of now, okay? So we will assume halogens are -1 and so this will be +3. That's how we are applying it. Okay, now gallium changes from 0 to 3 so that undergo oxidation, and bromine changes from 0 to -1 that will undergo reduction. Okay, question. What type of reaction is this? We learned 5 different type of reaction. What are the 5 different type we learned? Synthesis, decomposition, single, double, combustion. Okay, what type of reaction is this? Combustion? Single replacement. Okay, next one. Next one. Is it double? Single. Next one. Synthesis. Next one. Double. This one.
Splitting. Never mind. What is this? Yeah, what is this?
wait, what? This is not the
It's not a thing. Okay. Okay. So that's removal of atoms. So I'm gonna, this one get replaced. So I'm gonna write what? So one element get replaced. So I will go with a single. That's not a completely single replacement. You can write like that. It's a replacement. Okay. This one.
Combining.
Synthesis. And this will be double. And this will be.
Combustion.
Why? You have a problem with the combustion? Synthesis. Okay, now question. Which of these types are not redox? Double replacement will never be redox. So, circle the following types of reaction always tend to be a redox. And double replacement will be only just interchanging the ions. There won't be any losing or gaining or transfer of electron happens there. So we can say double replacement. If you see a double replacement, you don't need to do all these things. You can just say it is not a redox reaction. Question. Yes. That's not a question. Yeah, you may. Any other question? Okay, so